Dear all, welcome to today's lecture video on computer design and analysis. So in our previous class, we had seen what is geometric modeling and what are the different basic types of geometric modeling. So we defined geometric modeling as a combination of mathematical calculations and computer graphics. So combination of these two together make up geometric modeling. And we had seen the three different types of geometric modeling in very brief and the differences between these three. So we had gone through this table. Now let us see in detail the geometric modeling types. The first type is wireframe modeling. So wireframe modeling, as we mentioned, is a type of geometric modeling in which we will be able to see only we'll be seeing only the lines, the corners, the edges, etc. So the solid part of the object or the product will be missing in the case of wireframe modeling. We'll be seeing it as a series of lines, arcs, points, etc. And wireframe modeling was actually the simplest and oldest method for modeling the object. So wireframe modeling, actually, when even hand sketches were used in olden days, they used to create a wireframe model in order to understand what are the different corners or what are the different edges of the product, and they'll be representing the hidden areas using hidden lines, which we conventionally use in drawing. We use a hashed line or a dashed line to represent a hidden area, right, which is not visible for a particular viewing angle. So similarly, in wireframe modeling also they used similar kind of procedures, and it was the very oldest method. So it consists of a number of interconnected lines, points, arcs, etc., and represents the edges. So one of the disadvantage of wireframe modeling also we discussed that for very complicated objects it is very difficult to differentiate what is the shape because it is very confusing. Let us just go through the three different types of wireframe modeling, that is 2D modeling, 2.5D modeling and 3D modeling. So 2D modeling is actually a two-dimensional sketching process where we use only the XY plane. We have only two coordinates, x and y, and it is usually used to represent flat surfaces. Two-dimensional objects are, as we have drawn in our ZW CAD, the two-dimensional designing drawing, we will be using it to represent only the objects in a two-dimensional view. In 2.5D modeling, it represents orthographic projections. It resembles three-dimensional models, but it will not have side wall details. So the details will not be as much as it is in 3D. It is something in between two-dimensional modeling and three-dimensional modeling. That is why it is called 2.5D. Then we have the three-dimensional modeling, in which we use both the three coordinates, that is x, y and z coordinates, to represent the three-dimensional geometry of the object. So it is considered as a complete model of a solid object, that is three-dimensional modeling. So when we use a wireframe representation in all these models, then we can say that these are the types of wireframe modeling techniques. So we'll be using wireframe modeling technique in 2D, 2.5D and 3D. So this we had already seen in our last class. This is actually a die, and another example you can see, can you identify which product this is? It is actually a connecting road. So you can see how complicated the drawings are. Even if the shape resembles the connecting road, this is actually, you can say it is a three-dimensional view. But how complex it is, or how difficult it is to identify the shape, which is the front side, which is the back side. So it is very difficult because many lines are interconnecting, right? So wireframe models therefore are, or they can become very complicated when we try to draw complicated diagrams or models. But even then, wireframe models have their own advantages. First is, it is easy to construct. So whenever we draw a two-dimensional geometry in the form of lines, it is very easy to construct, and it is economical in terms of time and memory requirement. So whenever we create a two-dimensional model or three-dimensional model using a wireframe geometry or wireframe procedure, the space requirement is less. It will consume only less space and less memory. So that is why it is said it is economical, and it can be created easily, and it can be used to model solid objects. But the only difference is that you won't be able to see the solid, you'll be able to see only the lines and arcs, points, etc., and often used for previewing objects in an interactive scenario. So whenever you have to study or show a study of the objects, and what are the edges, what are the inner corners, hidden edges, etc., so this type of model can be used. Whereas if you create a three-dimensional model, it is very difficult to understand what is the inner geometry, how the object construction is made within the inside. Whereas in wireframe models, you can easily see, easily view all the corners, all the edges, all the inner portions, etc. So it is very easy to understand the geometry of simple models. And even for complicated objects, if you try to change the viewing angle and then see each and every corner, then it is very easy to understand. But with one particular view for a complex object, it is difficult to understand the geometry in the case of a wireframe model. Now, what are the advantages of a wireframe model? We have seen some of the advantages. Again, simple and easy to create, and it is the basis or the basic structure for creating a surface model. So whenever we are creating a surface using certain softwares, first of all we have to create a simple wireframe model so that we can extract or generate a surface from the wireframe. And computation time, CPU time required is less because it is taking less memory, so that we have already seen. Now let us look at the disadvantages. Again, creates confusion because a lot of interconnected lines are there, so it is very difficult to differentiate between the edges, sides, the inside and outside, etc. Then there is a non-uniqueness. So non-uniqueness means it is very difficult to identify which portion represents which area, and all areas look exactly similar. So similar means it is non-unique, it is not differentiable, so that is why it is known as non-uniqueness. Then again, wireframe models cannot be used for mass property calculations. Then surface removal, hidden surface removal, and again not suitable for shaded images generation, etc. Mass property calculations, for most mass property calculations we need a solid model. Whenever we create a 3D model, we create it as a solid model if we have to use it for certain analysis. So analysis, it cannot be conducted on a wireframe model. Then if you have to do certain hidden surface removal, Again, that is also not possible because wireframe has only lines, arcs, etc. And again, shading for certain edges or sides is also not possible in wireframes, and not realistic. You can see an example of a three-dimensional object being created here. So you can see the wireframe model of that object, and how or what is the object looking like. It is very difficult, which is the orientation, whether we are viewing from this angle or from below. It is difficult to identify. So complex models, it is difficult to analyze using a wireframe model. Cannot use photorealistic rendering tools. That is because we have not created any solids or any surfaces, so we cannot actually use the rendering option. Rendering, which we have mentioned in our previous class, it is giving the look of an actual real world object. If we have, or if we are modeling an object and we have to give it a appearance of a real world object, then we do a rendering process. So that type of rendering cannot be done on wireframe. And computational informations, etc., which you have already seen, that cannot be done using wireframe model. Now we move on to the second type of modeling, geometric modeling type, which is very commonly used for, especially in the case of objects where we have to do aerodynamic modeling. For example, in the case of aeroplanes, aircrafts, ships, automobiles, etc. So this type of modeling is very, very important in such areas. So surface modeling is actually a very important modeling technique in geometric modeling. So surface modeling is created from a wireframe model, or simple wireframe model. So for example, I think I have mentioned in the previous class also, whenever we have to create an object or a surface, then what we can do at first is we can create a wireframe. For example, I have created a spline. So now if I have to create a surface in similar shape, I can give the create surface option in that particular software, and it will generate a surface like this of particular shape. So what is the property of this particular surface? It will not have any thickness. Thickness will not be there. It will be just shown as a plain sheet of this particular shape or profile. If I am creating a straight line and trying to generate a surface, it will create a plain surface. It will not have any thickness, but a surface will be shown. A shaded surface area will be shown. So surfaces are always created from wireframe entities. So that is why it is given as a surface model is a combination of wireframe entity and a surface entity. So whatever shape you create, it is an arc. If you create a surface, it will just show a surface like this. This will not have any thickness. It will be just creating a sheet which is curved like this. Okay. And again, it defines geometry, and there is no topology. And shading or coloring, again, it is possible because we have created a surface, and the surface can be given certain colors or shades. So surface modeling, it is more sophisticated, more complicated than wireframe modeling, because it will consume more space, more CPU usage, RAM usage, and it defines not only the edges of a 3D object but also its surfaces. So this is exactly the surface model of the earlier die which we had seen. In the wireframe model, you had seen the same object. So in this, you were unable to identify what is the shape, but in surface model, you can easily identify the shape. But this is not a solid object. This is just a thin sheet. It is hollow if you look from below. It is a hollow object. So all these are surfaces that are generated. So you can change the color from blue color, you can give pink color, red, green, etc. So it is possible to give shading and colors. And you can use different entities or different options available in creating the surfaces. Like you can create a plane surface, a rolled surface, a revolving surface, cylindrical surfaces, etc. So all such entities or properties we can use in the case of a surface model. And two types of entities are commonly used in surface modeling, that is analytic entities and synthetic entities. So analytic entities include plane surface, a rolled surface, then a revolving surface like a sphere or a circle, etc., and a cylindrical surface, tabulated cylinder. And synthetic entities include a Bezier surface, it is actually a curved surface, and B-spline surface. So we'll be studying about all this in detail in our coming modules. So just understand for the time being that such entities are or can be made use of in surface modeling. Now, what are the advantages of using a surface model? It is less confusing. Less ambiguous means less confusing than a wireframe model. You can see, you can easily identify the shape. But the solid is absent. You do not have the solid, only the surface is present there. And uniqueness, you can easily identify or clearly identify which are the edges and which are the different corners, etc. The lines and points, arcs, etc. will not be seen here, and more realistic appearance is being shown because the lines are being removed, so you can easily identify all the corners and edges. And a hidden line and surface algorithm is being used for such a modeling purpose. So whenever we are creating a surface, in the background, as we mentioned earlier itself, in the background of the software will be running certain algorithms, certain programs, or certain calculations. So in surface modeling, when we create a surface, we'll be able to see only the surface and not the line. Once we create a surface using a wireframe or a line, so you have created a surface, but after you create a surface, that line will not be shown, only the surface will be shown. That is because in the background algorithm is being run by the software, that is hidden line and surface algorithm, a type of algorithm, one of the algorithms that is being run. So what the algorithm does is it will remove the line or the hidden lines that is coming in between the surface. So actually how the surface is generated, you have infinite number of lines. If you look at a wireframe model of such a surface, it will have an infinite number of lines going like this and this. So all these lines will be removed by the algorithm, and it will be showing the surface as a plane surface. So you won't be seeing any lines, you will be only seeing the corner and all the edges and the surface, only the surface and not the line. And again, if you have to do certain amount of volume and mass calculations, or if you want to do certain analysis, it can be done in the case of a surface model, whereas in wireframe modeling it was not possible. Then wireframe The surface models, as I told you, it is actually very important and finds its application in mostly areas which involve aerodynamic calculations, such as in aerospace industry, like aircraft manufacturing, then in ballistics, like missiles or rockets, etc., then in automobile industry for two-wheelers, three-wheelers, etc., four-wheelers, etc., and also for large automotive vehicles, again for locomotives, trains, and ships. So wherever transportation and logistics is involved, mainly transportation is involved, and again weapon industries, such areas where aerodynamics or aerodynamic calculations are involved, surface modeling is very important. So there we can use surface modeling. Then what are the disadvantages of a surface modeling technique? Again, we can only have the surface. Suppose if you are creating the surface of a curved object, you are creating a surface, you do not have any information on what objects or what are the objects lying below the surface. It can be hollow or there might be another surface, so there is no information about the interior of the objects. What is there on the inside of this? There is no information. And again, if you are trying to do certain computations on a surface model, it becomes very complicated, because it is not a very we do not perform computation on a simple surface. Whenever we are creating a surface, it will be the geometry will be very complicated, so we have to combine a number of surfaces finally to get the entire surface model. So the computation will become very complicated and requires more CPU time and memory when compared with the wireframe model, because the geometry is more, so more CPU usage, more memory usage will be there. Then coming to the third and most popularly used type of geometric modeling, that is solid modeling. Solid modeling is nothing but we are creating the solid model of a three-dimensional object. Whenever we are creating a three-dimensional object using a software, it is called a solid model. So solid model will show all the corners and edges and the surfaces. So it will be created as a, whenever we create a solid model, it will be created as a complete three-dimensional solid model. So it won't be hollow, the material will be present at the inside also. So it is a complete three-dimensional solid model. Most powerful 3D modeling technique. And the object created is defined by its vertices, edges, surfaces. It will have a weight, it will have a volume. So whatever we can assign, if we have to assign weight and volume, we can easily do it. Suppose we are creating the model, we have created a three-dimensional figure or three-dimensional block, and we say that this particular block should represent GI, galvanized iron, or say cast iron, or any other type of steel, say stainless steel. We can easily assign the properties of such materials to this block by giving certain values. Then the boundary of the model separates the interior and exterior of model object. So there is a boundary at the edges, at the vertices, etc., and it will separate the interior and exterior. So we can identify or we can show what is the interior and what is the exterior of the three-dimensional model. So here you can see this is actually the three-dimensional view of the object. This is the solid model and this is the wireframe model. You can see how easy it is to know the shapes and what are the features. Features means the different edges, holes, the projections, etc., that are available in a three-dimensional model, that is called as feature. So these features can be easily visible in the three-dimensional solid model. We can see here there is a flange, there is another flange here. Flange means projected surfaces like this, we call it as a flange. For example, suppose we have a L-shaped object in which this is the corner. So if we are creating a feature like this, a solid feature like this, for example, if we are welding it like this, then this is known as a flange. Projected area is called as a flange. This is that shape. So it is actually a projected area which connects or which is joining two different objects or features. So this particular feature we call it as a flange. So such features can be easily identified using a solid model, and you can see how difficult it is to identify those features in a wireframe model. And there are a number of ways of representing solid models, or they can be created using different methods: primitive creation functions, constructive solid geometry, sweeping, boundary representation. So these are different techniques by which we can represent a solid model. So in this, the most popularly used type is the constructive solid geometry. We'll just see in brief what is constructive solid geometry. So in constructive solid geometry technique, also known as CSG technique, the shapes, all the three-dimensional shapes, we have different three-dimensional shapes of objects that are already there or stored in the database. Like you have a block, then you have a cylinder, then you have arc-shaped objects, three-dimensional objects, etc. So all these are very basic type of objects which we call primitive objects. It is already there. So different shapes are produced for the 3D model by either adding or subtracting one or two different shapes. For example, if we are combining these two shapes together, then here you can see we'll be getting the three-dimensional model like this. So the final model will be looking something like this. When we combine these two objects, finally you'll be getting a shape like this. So this is the final shape. So in order to obtain this shape, actually we have combined two different objects, right? So that is known as A union B. You have two different shapes. One is A, the other is B. If you add these two, that is A union B, gives this shape. If you want to get the shape like this, then we subtract one shape from the other, that is A intersection B. So A intersection B here means which is the area where both of these have in common, the common area, this area. That will be given as the result. And sorry, A intersection B. And if we have to subtract one area from the other, then we do A minus B operation. That is, if you are subtracting one area from other, then we will be getting the resultant figure or resultant area like this. So we have A union B, A intersection B, and A minus B. So this technique of creating different shapes or 3D models by using primitive shapes or basic shapes, we call it as constructive solid geometry, CSG. And these operations, A union B, A intersection B, A minus B or A plus B, all these are known as Boolean operators. Union, intersection, difference, addition, all these are Boolean operators. So we use Boolean operators to either add, subtract, intersect, or to uniate different primitive blocks. So again, this is a time consuming process, and if you have to create very complicated models, it will take very lot of time, very good amount of time. So we have different other functions which will help in creating complex objects, such as the Boolean operations, again which we discussed, Boolean operations in combination with other functions like lifting, sweeping, swinging, rounding, etc. So if we combine all these operations together, easily we can create a solid model with a very complicated geometry. Then there are 5 different groups of modeling functions. These are the modeling functions which are generally supported by most solid modeling systems. So whenever we use a solid modeling software, we will be using a combination of all these different operations, like primitive creation, then Boolean operations, lifting, sweeping, swinging, and rounding procedure. Let us see some of the advantages. Solid modeling, it is not at all confusing. We can clearly identify the geometry of the solid model. Hidden lines are not visible, so it is very unique, more realistic appearance. And again, here we use the similar algorithm which we used in surface modeling technique, that is hidden line and surface algorithm. So it will give a more realistic view of the three-dimensional model. It will support volume and mass calculations, finite element modeling and analysis can be performed, and quality of designs can be improved because we have a very good idea of how the product will look like in three-dimensional view, because we are actually creating the model. Improves visualization, can be used in computer integrated manufacturing and computer aided manufacturing, etc. That means whenever we are creating a three-dimensional model, we can do certain analysis and then we can send that model directly to be manufactured by using computer aided manufacturing or computer integrated manufacturing techniques. But certain disadvantages are also there, because three-dimensional solid models are more complicated as far as computation is considered. So it will take a lot of RAM, a lot of memory, a lot of space for storing the files. So it requires more powerful computers. And now let us look at some of the softwares that are being used for the computer-aided designing, computer-aided manufacturing, computer-aided engineering, and also for process planning, computer-aided process planning. So process planning actually means that we are planning the entire production process, planning and scheduling the entire production process, right from the entry of raw materials into the manufacturing organization or firm until when the final product is being released to the market. How the scheduling and planning should be made, that is being done using computer-aided process planning techniques. Okay, so let us look at the details of such softwares in the coming class.